right, we're about to get started. Again, my name is Kiana, and I'll be one of the moderators this evening. I would like to first introduce our four speakers of tonight. The first speaker will be Molly Wolford. She's a senior proposal writer at the Qualcomm Institute. So, yeah, she'll be our first speaker tonight. Our second speaker will be Dr. Sean Carroll, who's also a research professor at Caltech in the physics department and at the Santa Fe Institute. And he'll be talking a little bit about podcasting and social media. Our third speaker will be Lyra Borditsky, who is an associate professor at UCSD in cognitive science, and she's also the editor-in-chief of Frontiers in Cultural Psychology. So she'll be our third speaker. And last but not least is Dr. Laura Zahn, who is the senior editor from Science Magazine, and she'll be here to talk a little bit more about careers and interview processes. So, yeah, I'm sure you guys are tired of hearing me talk, so why don't we welcome our first speaker.
Hi. As she said, my name's Molly Wofford. I work at the UC San Diego Qualcomm Institute, and I'm one of those rare individuals who actually enjoy writing grants. In case you didn't know, NSF's proposal preparation guide is 192 pages long, and NIH's instruction guide is 312 pages long. So with those kinds of page counts, you might think that writing a grant is a complicated process. But actually, it's really quite simple. And so I'm going to tell you how to be a good grant writer in 4 easy steps. The first step is to use your imagination. This cartoon here is actually a cartoon of me at a networking event telling people that I'm a fiction writer in the grant proposal genre. And that's a joke, but when I say use your imagination, I actually do mean make stuff up, be creative, go ahead and get crazy. But do it before you actually start writing. It's very important for you to sort of imagine all the far-fetched possibilities of your research, because if you're going to have a career as a researcher in academia, you're going to need to have multiple funding sources. So go ahead and dream up all the possible crazy applications of your research and be ready to apply that to all kinds of different funding sources. No matter where you're looking for funding, though, every grant has to answer 3 core questions. Those are, what's the problem that you're solving? What's the novelty and innovation of what you're proposing? And what are your qualifications for completing this project that you're pitching? If you can answer those questions uniquely and really know them, those are going to be your strengths in your proposal. So take the time to think about those answers and imagine the possible impacts of your work. This step is actually, I would say, possibly the most important step in grant writing, and it's always overlooked. It's possible for you to write a grant that's fantastically written, beautifully written, but if you can't tell them what is novel about your project or articulate why your research is important, you won't get funded. So imagining your research and brainstorming ideas before you start writing is important. Then you should do some research. NSF and NIH both have databases of all the awards that they've funded, so go ahead and browse that. Find out what they've found interesting and what they've gone ahead and given money to. That's a good way to know what they're looking for. It's also a good way to know what ideas are saturated. So if you're going to pitch an idea that's already been funded 100 times, chances are you're not going to probably get a good score. Because it's oversaturated. So when brainstorming, don't be afraid to think outside your field. Find collaborators, particularly here at UCSD. There's all kinds of people you could work with and find new branches of funding. For example, I work with someone in the School of Engineering who is working on an open source platform for speech recognition. He's found some great funding from both NIH and NSF for the hearing impaired field. But recently, he found a collaborator in the School of Medicine, and now he's branching off into a whole new area of funding in Alzheimer's research because of the connection between hearing impairment and isolation, which can lead to cognitive decline. So, now that you're brainstorming and you're kind of warming up your brain, getting ready, step 2 is follow the instructions. On the surface, following instructions may not seem related to good science communication, but in fact, following the rules or not following them can send a very specific message to your reviewers. It can tell them that when you follow the rules, it tells them that you've read the instructions, that you respect the agency, and that you've put some time and effort into your proposal. If you don't follow the rules, more importantly, if you don't follow the rules, your grant's just going to get tossed in the trash and not read. It's important to know that your grant is not the only grant that's being read, and reviewers are more often than not looking for a reason not to fund you, just as much as they're looking for a reason to fund you. So when you follow the instructions, you are giving them a reason to keep reading. Never give them a reason to not, to stop reading your proposal. So before you start writing, follow the instructions. Read that solicitation all the way through and understand what the agency is looking for. I would suggest that you create an outline, because the nice thing about grant proposals, particularly NSF and NIH, is they'll spell it all out for you. They'll tell you exactly what they want. They'll even tell you what font to use, what headings to use, and what they want you to talk about. So read that solicitation, create an outline according to that solicitation, keep that solicitation near you to refer back to as you're writing, and then make sure you tailor your message to what they're asking for. For example, if they're telling you they want you to have a paragraph about sharing knowledge, don't talk about, intellectual property protection when you're supposed to be talking about sharing knowledge. Always tailor your message to the funding agency and make sure you're letting them know how your research will further their mission, not just your own. So, now with that preparation, you're ready for the fun part. Step 3, be persuasive. Sounds simple. You might note my cartoon got color here because now things start to get really interesting. This is going to be the meat of writing your proposal. It's important to remember that grant writing is not the same as writing a report. It's not the same as writing a journal article. You are at the heart of a proposal asking somebody to take action. You want them to give you money, so you have to be persuasive. Ways that you can do that is, first and foremost, if you've done your preparations, your brainstorming and your preparations in step 1 and 2, you should know your problem and solution. You should know very clearly what problem you're solving, how you're solving it, and how it's innovative. Knowing decisively what you want to pitch before you write will help you organize your thoughts and write with confidence. Make sure you know what makes your project special. One way to test the clarity of how well you know what it is you're pitching is to try and write a log line. That's a 2-sentence summary of what is you're proposing and what the innovation is. If you can't boil your project down succinctly, then your project, your proposal may not be focused enough, and you might want to rethink it. Put that log line, if you've written one, at the end of the introduction. This is a great way to segue into your rest of your proposal. Speaking of the introduction, use it to your advantage. It's an overlooked part of the proposal, and it's one of the few places where you can actually let your passion for something show through. A good introduction is going to be like an elevator pitch. It's going to intrigue the reader, it's going to make your case, and it's going to make the reviewer want to keep reading the proposal to find out more about what this is that you're proposing to do. So use the introduction to your advantage, and use that log line to set up the rest of your proposal. As you're writing, don't be afraid to be bold. Make dramatic statements. If you think that your work is groundbreaking, go ahead and say it. Say the work that you're doing is groundbreaking. Say that what the problem you're solving is urgent. Make those statements, but then back them up. Remember to cite resources and use citations to support everything that you say so that you don't sound like you're fluffing it up or being, BS. So, also, speak authoritatively when you're writing. Say things like "we will," not "we hope to" or "we aim to," because speaking authoritatively gives a level of confidence. Using bold statements adds a level of emotion to your writing that will help connect you to your reader. Most importantly, remember always as you write to keep the reader in mind. Remember that your reader only knows what you tell them, so don't ask them to make leaps in logic. Spell things out for them, connect the dots, and when making a point, always bring your discussion back to your project. Always keep reminding them what this proposal is about. That's your first draft. So in your first draft, you're working on getting all the content in that the solicitation asks for. In your second draft, and your third, fourth, fifth, and sixth draft, you're trying to hone your message and the clarity and focus of your proposal. In order to do that, one way to do it is, as I said before, bring your discussion always back to the project. So if you just spent hours talking or paragraphs talking about, a problem with battery life in wireless devices, make sure that that last sentence in your paragraph is going to say how you're going to solve that problem with this project. Limit paragraphs to a single point or a single idea and use topic sentences to introduce that idea. Then talk about that point, the battery life, and then sum it up by bringing it back to the project. Also, use format for clarity. Space limitations is always a problem in grant proposals. So you can use headings as transitions. You can also use headings to sort of guide the reader through your proposal. When you do use headings, use your formatting, use color, bold, underline, italic to separate main headings from subheadings. This way, reviewers who don't actually read your proposal word for word, they can sometimes just skim through it, find the main points, and they don't actually have to read every word of your proposal to understand it. Your main goal in any proposal is to keep the reviewer reading and make it easy for them to get through your proposal. Another way to do that is with figures. They add visual diversity, and they can be important, but use them wisely. A good figure will illustrate a major concept, something that's maybe complicated and hard to understand in text, but is easy to visualize, better to understand with a visual, or it should add to the discussion. Never just repeat stuff that's in the text in a figure. It should add to the discussion and make something easier to understand. So the final step is to go ahead and submit your proposal, and then hurry up and wait, because it's going to take a good 6 months to hear back from anybody. But that's okay, because once you've submitted, congratulations, you are officially a grant writer. And the good news about grant writing is that the more you do it, the better you will become. So go ahead, start brainstorming, never too early. You can do that right now as you get bored, let your mind wander, start thinking about your research and things you can do with it, and come up with some good ideas. And then get writing. Thank you.
Thank you, Molly. So Let's welcome Dr. Clara. Thank you so much.
No, I'm just going to close that.
Okay.
This here,
Do I have to connect?
there. I don't need that. Don't need any of that. Thank you. Thank you very much. So I've decided to talk about, there's a million things to talk about. A lot of things are relevant to this, but I want to talk about podcasting, both because I'm doing it and it's fun, and there's not necessarily the idea that you will create your own podcast, but in the modern world, you will probably appear on a podcast before too long. Probably your friends have podcasts, and I think that the lessons that we learn from thinking about it actually extend to other ways of interacting with the public more generally. So I'm Sean Carroll. This is my podcast, Mindscape. That is my cat, Ariel, trying to appear on the podcast. She sometimes appears in the background, but has not yet been a featured guest. Some of you might not even know what podcasts are. It's a very interesting thing where, to many people around right today, it's kind of like video games. There's a culture where this is just the most important thing out there, and millions of people are part of this culture, and there's a much larger number of people who have no idea what is going on around them. So podcasts are basically radio shows that you make over the internet. You know that for TV shows these days, it's the rare person who actually says, oh, it's Tuesday, 8 p.m., I need to watch this show, right? The shows just appear, and then they're in the queue, and you can watch them, you can binge them whenever you want. Podcasts are the same thing, but for radio shows. And it makes, a radio show is something that is way easier to create than a TV show. So you don't need to be a big corporation to do it. You can just do it as an individual, like I do. There's no one out there editing or recording my podcast. It is all me. And sometimes people do a video version of it. They can videotape it, put it on YouTube or whatever. But usually it's just an audio show. And then there's dedicated apps that you can have on your phone or your computer to listen to it. There are many popular podcasts for those of you who are not experts. And one of the things to take away from this is the heterogeneity of the idea. You have some very big names. I wonder if this is a laser pointer. Yes. So NPR is huge in the podcast game. They produce a lot of very high quality podcasts, and they're very NPR-ish. There's a lot of music and a lot of heavy editing and things like that. There's sort of recycled things like the TED Radio Hour. They just take TED Talks and turn them into podcasts. There are specialized podcasts that tell a particular kind of story that just wouldn't have a medium otherwise. And there's, podcasts where it's just an individual interviewing people. They start small, and if people like it, they can grow. So 84, when I did the research for this a year ago, 84 of the top 200 podcasts are just one person basically doing it. The genres are very broad, but you do see some patterns. Comedy and news are two of the absolutely biggest things, society and culture. But there's science and medicine. It's pretty good, right? History is remarkably good. There's a lot of people interested in history podcasts. But these are more or less what you would guess. But there's a large variety of things that you can listen to. And of course, the wonderful thing about the modern technological era is you can hyper-specialize, right? You can listen to exactly what you want. We do not just have 3 channels that everyone listens to anymore. The total audience, very large and obviously rapidly growing. We're still in the exponential growth phase of podcasting. So 2014, 41 million podcast listeners. A few years later, by next year, there will be over 132 million podcast listeners. So even if you are not a listener, you know people who listen to podcasts all the time. And it's hard to read these terms over here, but it says 64% of the US population is familiar with the term podcasting, 44% has actually listened, 26% listen every month. So it is actually a large number of people who are out there listening to these weird things called podcasts. And here is the, I want to give you an idea, because this is always a thing where there's something like publishing a book or giving a talk or having your own podcast. There's a median, and then there's a mean, and these are very different things. There is a broad spectrum of reach that you can have in this game. So the best numbers I could find were from 6 or 7 years ago. The average podcast gets 141 downloads. And a download is basically a potential listener. Like, you can download it without actually listening to it, okay? So you do a lot of work, you get 141 people. It's not great, and that is the mean. That's the typical podcast, what they get. If you're in the top 10%, in 2013, you got over 3,000, so then it begins to become worthwhile. Top 5%, over 9,000, and then once you get in the top 1%, the ultra wealthy, then you begin talking real numbers, over 50,000 downloads per episode. And the top few get over 1 million downloads per episode. The Joe Rogan Experience has about 10 million listeners for a typical podcast episode, and he makes several a week. So he has a lot of listeners. That's why it mattered when he endorsed Bernie Sanders. Within science podcasts, there's a rich ecosystem. Even just when you say science, there's still a lot of different kinds of podcasts out there. So Stargate Universe is just a bunch of people talking about this week's interesting things in space and science. Ologies is an individual podcast by Ali Ward who just talks to a different expert in a field. Ideally, a field that ends with the word ology, like anthropology or cosmology or whatever, but I think that she goes beyond that if necessary. Official podcasts, science. We're going to hear from an employee of Science Magazine. AAAS puts out a podcast. NASA puts out a podcast. Science Friday basically is a podcast, etc. There's comedy science podcasts and so forth. So again, all the different kinds of possible genres are out there. My podcast, which is called Mindscape, is, I've been on many podcasts before I eventually decided to do my own. It's a moment of weakness. Once you start, then you feel you have to keep going. But actually, it's been fun. And there's a bunch of reasons why I didn't want to start my own podcast. It's work. It does take time to do it. I have a day job. I'm a professional scientist. I do research. That's what I'm supposed to do. How in the world could I actually take the time to interview people or stuff like that? So part of me said, well, I don't want to do any of that. That sounds like work. So I want to just do all the talking myself. The podcast will only be me every single week. And then I quickly came to my senses and realized I don't have nearly enough things to say. It would get boring very quickly. And I thought about, having a partner, and that also sounds like work. So I think the sweet spot for me of doing the least amount of work while still making it productive was just me talking with one person, and I can do that every week. And I'll get into the details of how it's produced. But the real tipping point was I wrote a book called The Big Picture, where I talk about physics and cosmology, but also about philosophy and neuroscience and biology and things like that. And so I was talking in the book about a lot of topics I am not an expert on. So unlike my usual books, which are about things I'm an expert on, I had to interview people and to learn what they think about these issues. And to my wonderful surprise, I could just email some Nobel Prize winner in biology and say, hey, could I drop by your lab and talk for a couple hours? I'm writing a book. And they would say yes. But then when my book got done, I no longer had any reason to do that. Just drop by smart people's offices and talk to them for an hour. So I decided if I had a podcast, I could tell them I would like to talk to you and put it on my podcast, and they would say yes again. And it's been a remarkably successful strategy. I've talked to Nobel Prize winners, Pulitzer Prize winners, MacArthur Prize winners, Emmy Award winners, Grammy Award winners, etc. It's been a lot of fun. As you can see, even though I'm a physicist myself, I do not necessarily bother to talk only to other physicists. In fact, there aren't any other physicists in the last 8 interviews that I've done. I talk to people who think about politics and music and a whole bunch of different things. I talk for about an hour or so. Again, Joe Rogan talks for 3 hours. Don't know how he does it. A lot of it is he does zero preparation and just sees what happens. I have a little bit higher standard than that. Like I try to read someone's book or something like that, or at least, I will confess there are times when my preparation for my podcast is listening to my future guest on some other podcast. That is a very convenient way of getting things done. But you always try to be a little bit different. All right, nitty-gritty, if you did happen to want to do this, this is where it became work. The actual running of the podcast on the week-to-week basis, it turns out not to be that much work, but there's a huge amount of work to get it set up in the first place. So if you have professionals doing your sound recording and editing and so forth, you can get really high sound quality. I didn't have that, so my strategy was just to do the research and invest in really good equipment, hoping that would compensate for my complete lack of expertise. So I have very nice microphones, recorders, the whole bit. Happily, I live in Los Angeles. There's all sorts of little shops where you can buy your audio recording equipment. That's very easy to do. So I did that. I actually have a web page on the podcast site which lists all of my equipment if anyone wants to duplicate exactly my setup. And then even more work was setting up the infrastructure for getting it done. So of course you have to have an audio file that you record, but then it doesn't do you any good unless you release that audio file to the world somehow. So you have to have what is called a podcast host. There is some company, just like a website host. If you have a website, some other company hosts it and you log in. Well, you have a podcast host, and that's a little bit different because the thing about podcasts is there's a lot of gigabytes involved. Podcast hosts are specialized to transfer enormous amounts of data relatively cheaply. So if you're lucky and people actually listen to your podcast, there will be a lot of download gigabytes that you will have to pay for. And a good podcast host makes that quite affordable in a way that if you just had a regular website host, it would be prohibitively expensive. You do still need a website so you can share your podcast. I actually use a transcription service, so whenever I have my podcast, I send them the audio file and they transcribe the whole thing. So people can read it and they can also search it, right? So you can go to my website and you can search all the podcasts for certain words or whatever. You can make money, in principle, doing this. You need listeners to do that. You can make money either because people want to just give you money voluntarily. This will never cease to amaze me, but it's really quite nice. Patreon is the most well-known and obvious example of this. You say, sign up and to promise to give me $1 every time I release a podcast. And people will do it. Not a lot of people, 0.1% of your total listeners, but still they do it, and that's some money. If you're very lucky, you can actually sell ads. And again, it's not gonna keep you outfitted in Maseratis and diamonds, but still, it's very funny if you're a podcast listener, there are certain companies that just love advertising on podcasts, right? Blue Apron, the Mattress People, Kitty Litter is a famous podcast thing. So I've spoken ads for all of these different services. And then there's some technological things which are going to be interesting. Zencastr, I should mention, is one of the ways that you can actually interview someone remotely. So we all know there's Skype and there's Zoom or there's Google Hangouts or whatever. The audio quality of these is not very good. You're sending a voice over the internet and it degrades. And for the listeners to your podcast, audio quality is incredibly important. It might not bother you to be listening to someone over Skype, but if they're listening to it in headphones, the audio quality really matters. So what a service like Zencastr will do is you'll hear the person you're talking to, but they will be recorded locally. So Zencastr will record your voice at your computer, their voice at their computer, and then email you the file. So then you can glue the files together and get something that has never been sent over the internet. It's recorded directly. So then it becomes an issue of, does your guest have a decent microphone and headphones? And I'm at the point where I will literally just mail decent microphones to my guests so they can use them, because your laptop microphone just is not up to the task. And then, this is another little bit of work you need to do. You need to figure out how to edit your audio file, if only because, sometimes the phone will ring or whatever, and you want to edit it out. But also, you can do noise cancellation and, remove clicks and buzzes and things like that. So, happily, we're in the world of free stuff. Audacity is an open source software program where you can edit files, glue them together. It works really, really well. It takes, honestly, about 15, 20 minutes to learn the basics of it. It takes a lifetime to master, but it's very easy to learn the basics of it. And if you're curious about what it takes to do an episode, this is here to shock you, but then I'll try to talk you down from it. You choose a guest, you invite the guest, you do research. If the guest says yes, what has the guest done? Then you interview them, either locally or you travel somewhere. I literally did a podcast interview just an hour ago with our next speaker. So whenever you're traveling somewhere, you take advantage of being in the new area to interview podcast guests. Good advice. You record separately an introduction, you edit the file, you export the file to an MP3 file or a WAV file, you get the transcript made,
Then you write the show notes, you upload to your host, you publish the episode, you do a separate post on Patreon, you email to your email supporters, you have to edit the YouTube file because for some reason, even though it's only audio, people like to listen to it on YouTube. You have to indicate on Twitter that you've posted it, email the guest and you've told them, okay? It sounds like a lot of work. I would not be shocked if you said, I'm not going to do this, this is crazy talk. But to be real, it takes minutes to invite the guest, you email them. To do the research, it's up to you, from 0 to several hours worth of research. The actual recording of the interview, 1 or 2 hours. If it's remote, if you're local, if you actually travel to them, there's travel time involved. But then the entire rest of this process takes about 2 to 3 hours. All the cleaning up and editing and posting and all that stuff, there's a lot of steps, but they're not individually onerous. So honestly, the entire work I do to get a podcast episode up is an afternoon's worth of work. And so I can do this once a week, and it does not really make a substantive dent in my work time. What it does do, I'm reading a lot of books that I wouldn't have otherwise read, but I wanted to do that. I don't feel bad about that. Finally, to build an audience, if that's what you want to do, the best thing to do is appear on other people's podcasts. That's the advice I can give you. You can try other ways of getting people to know about your podcast, but interestingly, people have like sticky media preferences. If you want your podcast to be known, being on other people's podcasts is the way to do it. And I really like the medium. There's definitely pluses and minuses of doing this kind of thing, but there's a reason why advertisers are willing to pay for it. Guests, the people who listen to you, the audience, really begins to feel a connection to you in a way that they don't through other media. Even if you're an author in a book or on TV, it's intimate. They hear your voice. You're talking to them. They begin to trust you. They begin to look forward. The best thing is when I, as a physicist, have physics episodes and people like it, and then I'll do an episode on music or wine or something like that, and I get people who listen and they say, the only reason I'm here is for the physics episode, but I listened to it because it was yours and I actually really liked that. You've led them to somewhere new, and that's the kind of thing that science communication should be good at. Thank you very much.
All right, we will have our third speaker, Dr. Lear Borditsky. And one other note before we continue into this third speaker is that all of this will be video recorded, so it will be available online on the YCABLY website, so for future viewing.
Thank you so much. So I want to start by telling you something, how to do something, communicating to you. So let me read it to you. It should be familiar, all English words, good sentences and stuff. The procedure is actually quite simple. First, arrange things into different groups depending on their makeup. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you're pretty well set. It's better to do too few things at once than too many. Remember, mistakes can be expensive. At first, the whole procedure will seem quite complicated. Soon, however, it will become just another fact of life. So suppose you heard that in a public talk or a radio interview, and then you had to tell someone what it was about. Or in a week I asked you, what did I say at the beginning? What would you remember? Nothing, right? It made no sense. All the words were normal English words, all the sentences were fine, and yet it's impossible to form any mental representation of what I was saying. And the reason is I've made zero effort to make a connection between what I'm saying and stuff that you already know, things that you already have stored in long-term memory. So let me tell you this, let me read you this paragraph again, but before I read it again, I'll tell you this is about doing the laundry. So listen again. The procedure is actually quite simple. First, you arrange things into different groups, depending on their makeup. Of course, one pile may be sufficient, depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you're pretty well set. It is better to do too few things at once than too many. Remember, mistakes can be expensive. At first, the whole procedure will seem quite complicated. Soon, however, it will become just another fact of life. Now, it's trivial to understand, right? Everything is falling into place. It's falling into a structure. You guys feel that? Okay. So that's where a lot of science communication goes wrong. A scientist who's an expert in their field will say things that are perfectly reasonable, they're perfectly understandable to them, and yet it is failing to make a connection with something that someone already has stored in their mind, right? You have to let people in. You have to find some way that they can have a connection. And one way to make that connection is to do exactly what I just did, which is do a demonstration, let people have an experience, right? So I could have just stood there and said, hey, you know, it's really important to make a connection with things that people know, and you should try to, but it's so much more vivid if I can let you actually have the experience. I can actually let you have the experience of being confused, and then I can release you from that confusion with a little magic trick, and then you remember that experience that you had, and whether you remember any of the other things that I might say that are in a bullet point list, you're going to remember that moment of being like, oh wait, now it's all falling into place. So one thing I would say that's really important for communication of any kind, if you want people to remember what you say and understand what you say, you have to make it vivid for them. You, as much as possible, bring them into the experience. So if I'm telling someone about experiments that I did, I'm not abstractly telling them about those experiments. I'm inviting them to actually be part of that experience as much as I can. Make things into demonstrations as much as you can. Now, when you're speaking to an audience that you don't know what their background is, it's an audience that it could be people of lots and lots of different backgrounds. Another thing that's really important is to not forget the basics. So when you've become an expert in some field, you take so much for granted. You take so much knowledge for granted. So if someone, I study high-level cognition, if someone asks me a question about some experiment I did in language and memory, I could start telling you about that experiment. But what I've forgotten is that most people walk around thinking that their memory works like a camera and they just remember everything the way that it happened. And if my audience thinks that, then everything that I'm telling them about my experiment doesn't make sense, because we're starting with very, very different assumptions about how memory works. So you have to go back to your first class, your Psych 101 class, your Bio 101 class, and remember those mind-bending moments you had in that class. And say, what were the things that I didn't know before I took that class? What is the groundwork that I need to lay so that the thing that I'm saying doesn't sound like I'm just an alien talking, because I'm completely disregarding the assumptions that people already have about how memory works, or about how DNA works, or about how molecules work, whatever it is, right? So often we're very eager to tell people about exactly the thing that we did, but actually it would be a lot more useful for you to just tell them the very basics of your field. Those are the most exciting things. And even if you never get to talk about your experiment, that's better, because you said something useful and true and interesting that people can carry around and think about. So that's another thing. The way that you become a good science communicator is just to try to say things that are useful and true and interesting, right? So people might ask you questions. If you're a guest on a podcast, if you're a guest on a radio show, or even if you're just teaching a class and students ask you questions, you have two different responsibilities when you're trying to answer a question as an expert, as a scientific expert. One is to the person who asked you the question. You want to honor their question and what they said. But the other, much bigger responsibility is to the audience, right? So imagine the situation where you have, you're in front of a class, there are 200 students, one student asked a question. You're going to take up the time of all of the students to answer the question. That question may or may not be well-formed or well-founded. It may not be leading to some of the most interesting things. It's your responsibility to try to say something that's interesting and useful to as many people in the room as possible. And that's true in whether you're a guest on a podcast or you're giving a talk. Again, just think, what is it that really excited me about this field? What is it that really got me interested? Why do I think it's important? What would be most useful for people to know? Okay, so that's about thinking about what to say. The other is when you're giving a presentation in the moment, it's natural for people to feel nervous. And so people very often ask me, do you get nervous when you're speaking in front of large groups, or how do you deal with nerves? And so one thing I will say is it's very natural for people to feel nervous. Of course, you're going to have a little more energy when you're about to stand in front of a group of people and talk, right? it would be very strange if you didn't, right? That's just physiology. But you have the ability to reinterpret how you feel that energy, right? So instead of thinking of yourself as nervous, in which case it's a negative thing, you're trying to contain it, think of it as being excited. We're actually very bad at telling the difference between different physiological states. We have what psychologists call undifferentiated arousal, so you can convince people that they're really, like, cartoons are really extra funny and that's why they're feeling jittery, or a potential mate is extra attractive and that's why they're feeling jittery, right? That kind of jittery feeling that you have, just use that as energy to power your talk, right? Your talk is going to be better, your presentation is going to be better if you are excited, if you're enthusiastic, than if you're bored, right? That is one thing that people often worry about. They're like, oh, I don't want to be sleepy on stage. Should I drink lots of caffeine? No one's ever actually sleepy on stage. Again, that would be such a physiological anomaly for you to stand in front of lots and lots of people and just like get too sleepy to talk, right? Your body will respond in a way that will power you. Like, you'll never feel cold on stage. You'll never feel sleepy on stage. You'll be just fine. All of those things will just take care of themselves. The other thing is, once you're in the moment of answering a question or giving a talk, the worst thing you can possibly do is think about yourself. Really, you are in the service of the people in front of you. Like, the most important thing is the audience. The way that you can get lost, the way that you can start feeling nervous, is to start thinking, oh, what are these people thinking of me? And as soon as you start, your focus goes inward, you lose your audience. Really, you're having this active interaction with people. And the more you're involved in whether they're nodding their heads and whether they're understanding what you're saying, the more you're thinking about what's in their minds and how you want to build knowledge for them, the better your presentation will be, the more easy it will be for them to understand. Another maybe obvious thing is that you just have to practice. And by practice, I don't just mean like when you practice a talk, you just stand in front of an empty room and practice, or you practice in front of your lab. I mean, just practice explaining things from your field to all kinds of people. Talk to people who are not experts in your field. Try to get across what it is that you think is so interesting and important. And the broader the set of people that you talk to, the more practice you get, like really understanding what people don't understand, what kinds of questions people ask you, what are the points of miscommunication, the better and better you become at really crafting the story that you can then deliver that story to just about any group of people, because you'll know what holes you need to fill in, because you will have had those experiences of miscommunications over and over again. Right? So if you're really passionate about communicating science, which I think we all should be, it's a duty that we have, then you just have to practice it. There's no way to know what other people might not know, what other people might not understand, unless you go out and try, right? And so just talk to people on the bus, talk to your roommate, talk to your friends who are not specialists. See how it goes. See what questions they ask. Refocus the way that you explain things from there. And I said that it's kind of I feel like it's our duty to communicate science to people. Everyone in this room is incredibly privileged, right? Society, culture has pumped all this knowledge into us. We have been invested with all of this incredible time and effort inherited from thousands and thousands and thousands of years of work by all these humans, right? And so we get to come to this very exalted place where we know something, we're experts in some field. Well, that is for the purpose of being useful to other people, right? At the very least, the least you can do is figure out what is it that I can do to help other people see the cool stuff that I do. Maybe I can tell them something that would be useful in their life, or tell them something that might open their eyes to something that they're not seeing, right? And so, because we have this incredible privilege, it is, I think, also our duty to do our best to try to communicate those things. I think I'll finish there and go to our last speaker. And I'll say, maybe I'll finish on this. Don't go over your time. It's always better to be shorter than to go longer.
And with that, I have much too long a presentation. I normally give a 1-hour talk on sort of alternative careers, and what I've done here Where's my computer? Yeah. Can you hear me through this? Okay. What I've done here is I did take some slides out, but it's not nearly enough. So I will zoom through some of the less important slides, and we'll try and hit the points that I think you guys are most interested in. So I'm going to talk a little bit about what it is a science editor does, because no one ever knows. I get told a lot, I want to be a science writer just like you, but I'm not a science writer. So I'm going to zoom through some of these slides, and you can ask me during the reception if you see something that's particularly interesting. But I'm going to talk a little bit about how, if you're exploring an alternative career that is one outside of doing research at a university, you could think about some of the tools that you can use to get it started. So let me get a timer on so I've got an idea of where I'm going. So my name is Laura Zahn. I'm a senior editor at Science Magazine. I'm responsible for life sciences and genetics and genomics more specifically. And my job is to identify the best research in my respective field. And there's a lot of work right now going on in genetics and genomics, and that's appropriate for the publication, which is Science Magazine. It needs to be really cutting edge. It needs to be novel. It needs to be a new finding or a new hypothesis. We're very international in scope. We've got about 45% of our papers are coming from outside of the US these days. And I need to maintain the editorial and scientific standards through the peer review process. And I need to be able to sort of oversee a lot of research that I'm not an expert in and decide what is the most exciting and decide to publish it and help the authors publish. So my main responsibility is finding the best manuscripts to publish. I decide what goes to review, I arrange for the reviewers, and I make the final decision on the basis of the reviews. Besides that, I do add some content to the journal. I design and solicit pieces for special issues or reviews. I travel a lot. I go to about 6 international meetings a year all over the world. I talk to lots of scientists. I do what are called lab visits and visit institutions, and I talk to scientists in my field. I edit the manuscripts for scientific content, and one of my best compliments was I admire your scorched earth editing technique, because we are limited in how many pages we've got. I interact with a lot of people, both at science and sometimes outside of science, like journalists, people in production, people in art. I don't write. I write like maybe 3 print pages a year. I write like an introduction to a special issue. I don't do any reporting for the news department, and I don't have anything to do with the podcast design or multimedia, although sometimes I get asked to provide input to make sure it's scientifically correct. So if you want to be an editor at a journal, generally you need a higher science degree, either a PhD or an MD. You need some postdoctoral experience. Not all journals require this. You need to have published some peer-reviewed research. But the most important thing is you have a broad interest in science, that you really, if you don't already have depth within your field and know around sort of the edges of it, you've got to be able to learn and learn quickly. So I had a pretty standard sort of typical scientist background. I have a BA from Smith College. I did a lot of different things in college, really explored what it was I liked, and I've always kind of come back to genetics. I've always loved that. I then spent 2 years as a research tech at Harvard, working on what was then the nascent Human Genome Project, and decided that I was more interested in sort of organismal questions. Ended up doing a PhD in ecology and evolutionary biology at the University of Arizona. I was a bad grad student. I was interested in everything. I had academic ADD, and it was really hard for me to focus, and I didn't necessarily have advisors that kind of reined me in and said, you got to look at one thing. And so I ended up doing a lot of different things in a lot of different departments, which served me really well now as an editor, but they were not good for being an academic. Eventually, they said, you've learned enough. They gave me my degree. I went and did postdoctoral work at Penn State, where I was able to focus, get a couple papers out, make a name for myself, start formulating hypotheses. But this project I was on is called the Foral Genome Project, and it was really multidisciplinary. And it was genomics, evo devo, molecular evolution, plant sciences. So you're starting to see a theme here that, you know, I like everything. And a lot of people want to know what it is I do. They say, like, what's a typical day? Well, I don't usually have typical days, but I do read a lot. I probably read most days between 20 and 30 manuscripts. That's about half my day, is just reading either my papers, other people's papers, or looking at what's been published in other journals. Doesn't mean I read every single word of every paper. Molly was giving some great advice. Besides putting together a grant, it's also very useful for putting together a scientific paper. I have a lot of administrative tasks. I need to arrange for my meetings and whatnot, and then edit a manuscript, things like that. So my least favorite part of the job is that I have to say no to a lot of very good science. We publish about 7% of what gets submitted to science. Most people think I've made a mistake when I say, sorry, we're not going to publish this in Science. And I take that quite seriously because, I mean, I know that I spent a lot of late nights as a grad student and postdoc in the lab. You put a lot of yourself into science, and there's not always a payoff. So I'm very aware of that. I also can't know everything. I make mistakes. Presumably peer review catches them, but you know, peer review is not perfect. Scientists do occasionally, whether intentionally or not, make mistakes. There have been examples of potential fraud that I've dealt with, or someone makes an error and having to deal with a retraction, whether or not the author agrees with it. And then sometimes there are conflicts of interest that you find out that like the reviewer had, and it makes you feel a little icky that you published a paper and it turns out that maybe they were a little bit more favorable of it than they might have been if they hadn't had that conflict of interest. But I get to be at the forefront of science. I know everything before everyone else, you know, except for maybe one author, but I get to see the whole landscape and I really have an idea of what's coming out. I get to work with lots of different types of research. I'm constantly learning. I get to travel. I telecommute full time. I live here in San Diego. My office is in Washington, D.C. And I really love talking to the scientists and going to meetings and hearing all the cool stuff that's going on. So now I'm going to transition a little bit and talking about sort of how do you get into a job like scientific editing? Well, it's considered an alternative career path. But there are a lot of alternative career paths. So some people have this idea that I became an editor because I couldn't hack it in academia. Now, I wasn't going to be a great academic. I might not have ended up in a research institution like UCSD. But when I left, you know, I had a colleague that I had co-published with who was in Germany, and they wrote me and said, you know, I'm really sorry you're leaving science. You're a really good scientist. And that was nice to hear. And maybe I hadn't quite internalized it. As an editor, though, I can see how being a scientist, having that PhD is very important for the way I go about my job. Your research is not your most valuable asset, and alternative careers are not necessarily boring. And in fact, some of them can be a lot more exciting than science. So whether or not you have the choice in terms of an alternative career, you're not getting the jobs at the research institutions you want. How do you find what's out there? Because there's so many different jobs. So probably the first thing you need to do is like research your options. There are a number of books about alternative careers outside academia. Lots of websites have information about various types of jobs. What do you like to do? Does the idea of reading 20 manuscripts a day just make your head explode and you're like, no way I could do that? I like to be at the bench, or I like to talk to people. What am I good at? What do I value? Do I really want a 9-to-5 job where I can be home every night for dinner? Or am I okay to be on the road, you know, 6 weeks out of the year or 6 months out of the year? What kind of income am I looking for? Would I be okay with, you know, a relatively low-paying job where I work sort of on a contract basis versus having a contract and getting a paycheck every week and having health care through my employer? So how do you do this? Well, one way you can do it is to conduct an informational interview. I just found out about this job. That sounds really cool. Maybe there's someone who went to the same school as me, whether it was your undergraduate, your graduate, or your postdoc. Maybe you can find someone through LinkedIn that has that job. You meet someone at a conference. They're doing something different. Oh, you work for that company. I was kind of curious what they do. Can I talk to you? So this is a little dated. This is from 2012. But, you know, the point is that there are a lot of different positions, and there are a lot of different things you can do. And a biology PhD, you can do a lot of different things. And it doesn't even have to be in the actual sciences. You can take that scientific mindset and you can apply it to non-science jobs. You have skills that you can sell yourself on, whether or not you're looking at a position in science. With a PhD or even a master's, you have demonstrated some ability to learn, data analysis and management, project management, communication, technical and computer skills, teaching leadership, problem solving and critical thinking, and technical know-how. These are all really critical. So even if you're not going to work at the bench, even if you're not going to be thinking about data tables or graphs or, how do you collect that information, you can use these skills in a lot of today's jobs. So having a PhD is a really, really valuable background for a lot of employers in today's market. I'm going to skip that one. And most people these days, about 1 in 5 are getting the tenure track job, and about 4 in 5 are doing what are considered alternative careers. So in terms of setting up an informational interview, it's a way to learn about your career options and expand your network. Write an email. Can I buy you a cup of coffee? Can I meet with you in your office? Can I get 15 or 20 minutes of your time? I'd like to ask you a little bit about your job. Don't make the assumption that they easily have an hour or two to spare. Most of us are really busy. I get a lot of emails saying, can you answer all these questions about your job? And I have to admit that I have to blow off a number of them just because I get so many. But, be persistent. Find other people if you can't get your first person to agree. Prepare ahead of time if you're meeting them face-to-face. Dress appropriately. Don't ask pointed questions. Do you like it, yes or no? Ask open-ended questions. What are the benefits and things that you don't like about the job? And let them answer what they want to. Mind your manners. Don't say, how much do you get paid? What can I expect? Do you have a position for me? Don't ask those kinds of questions. Ask for referrals. If I was interested in exploring this, do you know of places I can go to learn more about potential opportunities? And write a thank you note. That's always, that's good for just about anything when you're asking a favor from someone. You do have to consider the employment trends. Editing right now is very much based on the East Coast. Most journals require you to actually live where the journal is. So that means London, New York, Washington, D.C., or Boston for the majority of the scientific journals. Immigration. Are you going to need some sort of visa sponsor? And does that company sponsor it? Not everyone does. Your family. Is your spouse or partner going to be able to get employment there? Are they going to be happy there? So real quick, here are just so many different things you can do, whether with a PhD or some sort of science background. You can work in education, you can work in policy, funding, you can work in consulting or sales, business, publishing, government, law, medical, IT, for a professional or an academic association. There are so many jobs out there. It does take a little legwork. It's a little bit harder to find than coming from a university where everyone is looking for a postdoc or a professorship or maybe a teaching position or something like that. Something that you're very aware of because those are the people you're seeing day to day. Some questions to ask. What attracted you to the field? When I got into editing, I had no idea what it was an editor did. I thought, it might be cool to read a bunch of different science papers. And it turned out to be a really good fit, but I didn't know that when I accepted the position. So I thought, I'll take it and, I'll do it for a year. And if I don't like it, I can always get another postdoc. And, it turns out that within 3 months, it was clear this was my dream job that I just never knew existed. What do you like most least about this field? What's a typical day or week? How did you get here? What kind of skills do you need? How do I locate positions in the field? And, is there anything else you might suggest to someone who's trying to, start out? I will also say that, the more you can have on your resume that can make you stand out, the better the chance you'll have that, someone will take a chance on you, especially if you don't have experience for a job like this. If you have computer programming skills, make sure they're really clear on your resume. Fluency in another language, you study both biology and physics, or, you have a math BS, but, now you're doing biology or neuroscience. Make sure that's really clear. And when you go in, whether it's for a job interview or even an informational interview, be informed as much as you can about sort of what the position is, what the discipline is, know a little bit about the field, and know a little bit about what's going on in the world, to make small talk. Don't talk politics, but, hey, what about the Super Bowl last week? And, maybe the person doesn't do sports, but something very general that a lot of people are generally at least somewhat knowledgeable about. Where do you find this? Ask unbiased sources. Like I said, at a meeting, people have lots of jobs on boards at most meetings. Your career development office at the university, they're going to have a lot of information. There are a lot of websites. I'm going to promote sciencecareers.org. There are a lot of books out there. One of the things I did when I took the editor job is I read At the Helm, which is about how to run a lab, because I wanted to know what it was I might be missing if I chose not to be running my own lab. Alternative careers. I mean, if you just go on Amazon, there are hundreds of books like this now. And it doesn't hurt to reach out about a position that you're not 100% sure you want to do or you might not have all the qualifications for. You may have something that they don't know they want until they see your resume. I will say for me, they were not looking for a geneticist, but they loved the fact that I was one when they saw my resume. They hadn't gotten any applications from people who had my kind of background. Attend any career fair that's available, network. Just get it out there. I'm looking for a job in X. You never know, So you meet someone at a party, you say, hey, I'm looking for a job for X. Oh, well, that's interesting. My husband works in this field. Or, or my best friend does, or something like that. You never know. And if it doesn't work out, don't burn bridges. Don't say, sayonara losers, I'm going back to academia. You never know where you're going to meet a person in life. So with that, I will say that the Science Careers website has a lot of information, including my individualized development plan. It can be for students, it can be for postdocs. Feel free to check it out. We have downloadable booklets, including one on careers away from the bench. And then if you're interested in policy, the AAAS Policy Fellowships, they're very, very competitive. But if you're at all interested in working in an organization like NOAA or USAID, if you can get one of these, they actually put you in that institution in Washington, D.C. for a year, where you can develop the skills and work in this policy position. And I'm not sure exactly when the applications open, but they generally open in the spring and close in the fall. So with that, I'll say thank you, and I guess we're up for the panel, and you can ask any questions.
Awesome. So now it's time for our speaker panel. If I can have all of you, take a seat. And again, we will be putting up the slide for the link to the slido.com, so you can input questions there. Okay, and for now, we'll be also fielding questions, verbal questions. So, does anyone have any questions?
My question is for Sean. So you talked about how you started your podcast, but obviously you're established in your field, you're well known, so people, when they see your name, when you send them an email, they'll respond. What advice do you have for someone who whose name is not known?
No, that's a great question. It's the same as the advice for writing a best-selling book, which is first become a famous celebrity, right? And that's the tricky part. Being established helps, but it's not necessary. I've been on plenty of podcasts myself, hosted by people I'd never heard of before they invited me. I think the single most important piece of advice is don't be afraid of being rejected, because some people, I get rejected all the time when I invite people on my podcast. But I've gotten very pleasantly surprised by the people who said yes. I had Wynton Marsalis was one of my first podcast guests. He's the most famous trumpeter in the world. He had never heard of me, but he's like, yeah, sure, why not? I'll do it. Try and be polite, be respectful. Do not be upset if people say no, but explain who you are, why it is. Like if you send a one-line email saying, hi, I have a podcast you want to be on, that's probably not going to be good enough. But if you say, hi, explain who you are, you're a student, you're a researcher, I have a podcast that does this kind of thing, and I'm trying to do this,
there's a sweet spot. You don't want a one-line email. You don't want a 12-paragraph email either, because people aren't going to read that. But then, as long as you are clear and understanding and give it a shot, some people are going to say yes. Also, not all of your guests have to be super famous, right? Like if you're a student, ask other students. If you're a postdoc, ask other postdocs. Then these people often have very interesting things to say.
Hello, this is for all of you, actually. When you're at conferences or you're networking, is there a way you can avoid being a fangirl and being kind of silly?
So I hate networking. I'm a shy person. That like my nightmare is being put into a room full of people I don't really know and having to make small talk. And what I find is if you have a genuine intellectual question, a genuine intellectual point of connection, that's your best bet. You're going to have a great conversation. That person's going to remember you. That's the real connection that you're going to make. So for me, at least, and I think a lot of people in science are not natural extroverts. You just find the thing that actually excites you about that person's research. Ask a serious question. Make a real conversation happen. And that's the thing that brings all kinds of fruit down the line too.
I think, maybe just to echo that, I also don't want to talk to other people at conferences, but I don't mind when people come to try to talk to me if it's a genuine question and not, hi, I want something from you, right? Like that's the part that it rubs people the wrong way. It's like if you say like, hi, I'm interested in a job that you have, or I want you to be my collaborator, or I want you to spend time reading my paper, first indicate that you're actually interested in what they have to do. You're at a science conference, you're there to talk about science, that's okay.
I'm the person that everyone wants to come and ask me, are you interested in my study, my paper, whatever. And, it's fine to be direct about that. Again, I might say, oh, well, I've got a meeting right now. Can you email me? Ask, do they have a card? Not that many people carry them these days, but, some people have an e-card or something like that. Can I contact you, at another time? Is there another time at the meeting that you might have some time? Just be polite about it. You say fangirl, so I meet lots of world famous scientists, and sometimes you are a little awestruck. Like this person was publishing stuff that really got me launched in the field, and just remember they're human too. Okay, they may be a big name, but honestly, most scientists, if they go into Starbucks, no one's going to recognize them. They still have to pay for their coffee, so just kind of keep that in mind. People are approachable for the most part, and some people just are more brusque in terms of their personality, and you just kind of have to chalk it up to that's not going to happen today.
My answer would be no. There's no way to stop being a fangirl. Just try not to squeal.
Okay, there's a question from Silly.com. So the one asks, if someone wants a full-time career in science communication but doesn't want to continue doing research, what career path would you advise?
Science communication, there's grant writing, there's, you can also work for a company and you can do the promotional material, you can work as a press officer. You can translate science to English for people. There are a lot of jobs in that. You can work in advertising or sales. There are so many jobs, not just being an editor. Lots of them.
Thanks.
Academia is very unusual for having this extremely structured up or out thing where you're a graduate student, you're a postdoc, you're junior faculty, you're senior faculty, etc. Most of the real world, it's hard to know what to do next, and it's not obvious, and has pluses and minuses, right? Like, you don't know what the thing to do next to succeed is, but you also might be incredibly successful tomorrow having no idea what happened. So casting a very wide net, talking to lots of people, thinking outside the box about what the possibilities are.
I can just add a couple things. You can make science documentaries if you're good at filmmaking or producing TV shows. That's a really useful thing. That's how a lot of people get their information about science. You can be a science writer, of course. You can, I mean, any other mode of communication that people use. You can be a science advisor on a TV show, on a film, where you are the person who makes sure that the things that they're putting in are remotely reasonable. So there are lots and lots of ways for you to take all of the knowledge that you have and use it in some way to help people stay relatively close to what's true, what we know to be true.
Yeah, I mean, for this person who asked, look at some of the career websites, at Science, at some of the other journals, talk to your career development person. They can help steer you towards, how do you figure out which ones might be best for you?
And also don't be afraid to switch. I mean, going back to what Sean said, a very good friend of mine, after getting her PhD at Stanford in psychology, first edited a journal, then ran a science and technology museum, then ran a think tank for thinking about how to use scientific knowledge to foster social change, then worked at Instagram, is now at Twitter. There are all these opportunities for using all of the things that you know to help better the world. So, I mean, no one would have predicted that kind of career, but it's actually been an incredibly rich and rewarding path.
I have another question, actually. So when it comes to science communication to the general public or to people who are not experts in your field, I think for me a challenge has always been how to identify those details in my work that are not core to the message or to the findings, and communicate the core message. Without spending too much time worrying about the details, while also still remaining true to the actual science. What's your advice when it comes to that? How do you actually go about doing that? Communicate the science effectively, but also, you don't want to give the wrong impression using the wrong analogies and so on.
Yeah, it's hard. But you want to do that. I think that, what Lara already said was very important, that the people you're talking to are not empty vessels, right? There's this this metaphor that is only brought up to say it's the wrong one, of you're just pouring knowledge into someone's brain. But people already think they know some things, and they may be right. And you have to sort of see where they are and imagine where you want them to be. And it's a success if at the end of communicating with them, they are closer to where you want to be. You can't just say, okay, let's write down the Schrodinger equation and solve for some wave functions if they have no idea what a differential equation is or what quantum mechanics is or whatever. You're going to use some metaphors, you're going to talk some language, and hopefully they'll get closer to an understanding. And it's too easy to give the illusion of understanding, give some factoids, but try to give them some principles, something they can carry away and sort of apply in other ways without thinking that either it's got to be exactly right or it's not worth doing.
Yeah, definitely don't fall into the trap of thinking that you have to get it exactly right. I mean, other scientists will just about always be mad at something that you said on the radio because it wasn't, exactly what they think in the moment. I think what you're trying to do is do your part to get people from where they are to somewhere a little bit better than where they were before you started talking. You can only say a few things, and only say things that, be sure to only say things that are true, and only say things that are interesting, because otherwise why bother, and try to say things that are useful. But other than that, there's not going to be anything that's perfect. And also, our scientific understanding of most things isn't perfect either. So start with that humility that, we're all just trying to figure it out. We're trying to build on each other's knowledge, and you're just trying to help with that endeavor.
Also, sort of think about your family. I mean, there are probably some non-scientists in your family, and how do you explain to them what you do? basic terms. You don't have to, again, go into all the details, but, they know you go off to school and that you're complaining that you're spending all this time in the lab, and they want to know what you're doing because they love you. And so what do you tell them? And how do you expand upon that for, someone who is not your family but may not know? A lot of people just assume I'm immediately talking to a peer, and they're just as smart as you, but they just don't know because they haven't been in the lab the same amount of time you have. So just sort of think about putting yourself in the other person's shoes. And this is going to be really important because, like, as you start doing career searches and such, you're going to have to give interviews where not everyone is going to be in your field. You're going to have to give talks to departments and possibly even outside of your department. And so you really have to think about what's the basic introduction that people need to know to understand why I'm doing what I'm doing and what the context is. And that's really important in terms of science communication. And again, not every detail needs to be in there, but just what's the most important background that you can communicate so that people understand why it's important.
Yeah, and I think I would also add that in science, when you're giving a talk, you really focus so much on what's the new thing that you did, like what is the cutting edge thing. But often when you're talking to a very general audience, that cutting edge thing is just like the very, very tip of the iceberg of all the things that they don't know to understand the very cool thing. And sometimes the most useful thing you can tell people is something that's been known for 40 years in your field. It's just that they don't know it, right? So I started my talk today with an example that's more than 40 years old in my field. So if you're a cognitive psychologist, you've come across it in an introduction to psychology class. But most people haven't thought about it that way, right? And so instead of trying to tell people what's the new refinement that we made on the one blah, 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 just think, like, how can I get them most of the way there? Like, what's the most important thing that I can do in that moment of education? That, it's teaching, just on a much larger scale.
Hello. This question, I suppose, would be for everyone, although I'm most familiar with Sean, and his last response made me wonder if, in your wide variety of very interesting conversations that you've had, or any of you have had, I wondered, has your mind been changed on something, especially at your age, given all you know?
No, I know everything
at
now. I
your
don't need to
age.
change my mind about things. That was a fun part of my life when I was still changing my mind. No, I mean, obviously, there's like crystal clear times when my mind has been changed because of new discoveries in science, right? Like in 1998, we discovered the universe was accelerating, and I would have bet a lot of money that that was not true. So, scientists are always changing their minds about things like that. About fuzzier things, I think that there's a longer conversation to be had about how minds actually do change. I think that we have this idea that you have an opinion, and then someone gives you a crucial argument or a crucial fact, and your mind changes. And I think that, I don't know if there's a cognitive scientist here, but I think that never happens, essentially, right? Very close to never happens. But it doesn't mean that minds don't change. It means that, there's a great analogy. If you make pork butt in the barbecue, you put this hunk of meat in the steamer, and you put a thermometer in it, and what happens as it heats up? Its temperature goes up, but then it plateaus, and this is a known fact, and then it will start heating up again. And what happens is the temperature is remaining the same, but the meat is expelling moisture, and so it's changing. But if the only thing you're keeping track of is the temperature, it doesn't look like it's changing. And I think the same thing is happening with people's opinions about things. You give them arguments, you give them examples, you give them data, and their minds might not instantly change, but you're working on them. And it will build up, and a year later they'll say, oh, I never used to believe that, right? So I've certainly changed my mind about things, from morality to the rules of quantum mechanics, and many, many things, but it's not just because of some single magic bullet.
I would say that people don't necessarily change their mind, but they come to believe other things also. And so what you're doing is adding to the set of things that they believe, and the set of things that they believe may now more frequently include the things that you've said. And just to give you an example of that, if all of us have some intuitive sense of physics, a lot of which is wrong, right? So if I say there's a circular tube and I set a ball through the circular tube and I say draw a trajectory of the ball as it comes out of the circular tube, most people will draw a circular path, right? And that's not what happens. If you take professional physicists and ask them this question under time pressure, you see that they actually still hold on to that intuitive idea, even though obviously they know in another sense that that's also not true, right? And so we have a lot of intuitive ideas, folk psychology, folk physics, folk biology, that we hold on to no matter what, but then it also gets amended with all of these other things that we learn. So sometimes it's best to just trust that you're adding knowledge, and maybe that knowledge becomes more frequently accessed by the other person. It's hard to unlearn things that you already know.
It seems to me like one of the largest problems in science is sort of this wall of jargon that gets put over everything. And you sort of end up with science communication for other scientists who are experts in their field, who kind of have these keywords that they're looking for value and additions to what they know. And then you have sort of everyday people who really can't access that. For example, I sort of switched from machine learning to a more genomics oriented field, and it took me like 6 months of being in a lab, contributing, reading papers, and having these experts all around me sort of helping me out to understand. And maybe after 6 months, I can sort of tell my way what's the top and what's the bottom. And you go across the world, and most people don't have 6 months to work with experts. And this has to really be slowing the pace of understanding and of possible science. So I guess, do you think it's improving? And if not, how would you improve that issue?
I mean, what I can argue is that there are a lot of these science journals, and some people are saying we don't need them anymore, we'll just put our research on the internet. And the number of papers that come through that eventually get published in the same format after an editor's worked with it is very slim. There are a few that come in and they're wonderfully written and you really don't have to change anything, and they go through peer review and the reviewers say, fix this a little bit and then it's supplemental, and that's it. But that's like less than 0.05% of all the papers I've ever handled. The majority of them really need some editing. If I don't understand something, I can tell you the readership is not going to. We try to make the abstracts as understandable as possible. It's hard though, because we cross all these disciplines and they have like 125 words to get across like what they did and why it's important. We also have news, and many of them are not trained scientists, but they're very good at translating by talking to scientists and kind of getting at the nugget of why this is important and writing pieces on it. So, I can't say for an individual, but I can say that, there are a lot of professionals out there, people at newspapers, editors, many people who are working in science communication. Like I said, Illumina will have a new product, and they have people there to write their press releases so that people understand what this product is and what it does. And then they have salespeople who will go out and, again, explain what it is and what it does. So a lot of people, that is their talent. And, look at what they're doing. And there are some books and things that can talk about how to make scientific communication better. The more you sort of read and present, the easier it gets. So that's my experience.
I think it's very complicated because jargon is not purely evil. Like if you're a professional talking to other professionals, you need jargon. It's a shortcut. It's an enormous amount of information conveyed in a very short period of time. Some jargon is terrible because it's just not descriptive, right? Like I work in the physics and philosophy of time, and there's this famous paper on the nature of time that distinguishes between two possibilities. One is the whole extent of time is equally real, and the other is only the present moment is real and we move through it. And these are helpfully called the A theory of time and the B theory of time. And for the life of me, I will never remember which is the A theory and which is the B theory. I do not know the difference between type 1 errors and type 2 errors, and these are just non-descriptive, so I hate them. But none of them, even words that are descriptive, are helpful if you don't know what the words are. So if you're a good communicator, you need to develop a skill for figuring out at what level people are going to understand the words you use. And if you really understand a concept, you should be able to explain it without relying on those jargon words.
Okay, awesome. I do see one more hand. While she gets the microphone, we'll field some questions from the Slido. So one is, what are some options for education, jobs or volunteer work? I realize I love teaching, but don't know yet if I want to go the professor route.
I know nothing about this, but I can talk about it. No, I actually don't. It's a really good question, and it's a shame I don't know the answer because, as was alluded to, we have this belief that if you're in a PhD program, you're supposed to become a tenured research professor. And most people don't, so it's weird that we have that expectation. But one of the things worth emphasizing, which is, I don't know much about specifically pre-college education, but I think it's a broader lesson. All these other fields have their own standards and expectations of training and things like that, right? Journalists have training, teachers have training, videographers and cinematographers have training. And so I think that some people who get their PhD think, well, I can't or don't want to get a job as a research professor, so I'm just going to slum it by doing something else. These other things are really hard and require their own specialized knowledge, so I would get that specialized knowledge before I made a decision to do that for a living, or at least look into what that specialized knowledge would entail.
I might answer a slightly different question, which is if you're passionate about science, communication, and education, that's something you can do at any time, right? So if you're teaching a class, for example, when I was a grad student, I taught a class on sensation and perception, and this was in the dark early days in the mid-90s where you had to hard code your HTML by hand. But I put all my lecture slides and all my lecture notes online for that class. And there's one set of notes on signal detection theory that I just worked through in my head. How would I explain signal detection theory if I really wanted someone to understand it? And for probably 15 years, that was one of the top links on Google for signal detection theory, just because it was useful to people, right? And it just took a little. I prepared a lecture. I put time into the lecture. I put a little time to just put it online for free, and then all kinds of people would find it and ask me questions about it. And I'm not even an expert on signal detection theory, right? It's just something I knew well enough to teach it at an undergraduate level. But that's just something you can do anytime. If you're passionate about communicating things, if you think there are things that are useful that you know, and you have a good way of explaining it, people will find it. And just put it out there. And the more you do that, the more opportunities to do more of that will come to you, because people will see that you're good at it.
I'm going to answer a little bit different here and just kind of say, don't think that if you take a job, you're wedded to it, that you really have to keep it for life. You try it out. If it doesn't work out, you can leave. You can find something else. You may not want to leave until you know you've got something else lined up, but there are a lot of career coaches and such. They give you tests. They'll say, here's what your aptitude is. Again, the career development at a university, or if you're an alum, back at your former university, they have a lot of resources for these kinds of things to explore these types of questions. I mean, there are so many books out there, and you can really crack what color's your parachute, but there are other ones as well that are more specific to certain fields. So, use your local library, use your university library. There's a lot of information out there.
So my question is a general science communication question, so for the whole panel. So something I struggle with when I'm having discussions with people that are not in science is this idea that there's kind of uncertainty in science and that we're kind of changing our mind on things. But then, so a lot of things we believe now to be true weren't kind of a consensus at one point. And so it's good to keep an open mind. But then there are kind of these issues that I would say there is a consensus in science, but are kind of controversial in the general public, like climate change, for example, or vaccinations. And I'm wondering do you have any advice on how you can kind of appreciate that it's good to keep an open mind and that there is some uncertainty in things, but also be able to kind of advocate for the scientific process and how there is a consensus in science on these issues? And without actually knowing I've never looked at the primary data for about some of those issues, so.
Right. Well, so all of us humans are in that position. So everyone here believes that the Earth revolves around the sun and not the other way around. But very few of the people in this room would be able to provide right now on the spot the proof for that, or tell me how to reason through the fact that that might be true, right? So we have to defer to experts on lots of things. And so the way I always approach that question of uncertainty, as opposed to like, here are the things we know, is to say at any given point, the most rational thing to believe is the thing that's most consistent with most of the data that you have, right? So the most rational thing to believe is not that you know nothing, but given the data that you have, this is the thing that you should probably believe. And it could be that there will be a new set of data or some new understanding or some new theory that comes and transforms us. At that point, it'll be most rational to believe things that have changed in whatever way. But it would be absurd to say, well, it could possibly change at some point, so I should believe that everything is equal probable.
Hi, thank you for your presentations. They're really interesting. So I'm going to ask, it's probably a question for Sean, but I'm interested in opinions of the other panel. So I recently started running, co-hosting a science show here in San Diego, recently as of this January, so I'm pretty new to this. So think about the show as being like a TED Talk, but with booze, with alcohol, because we know that learning sometimes happens best when you're drinking and having fun with friends. But as I said, I'm quite new to this show, and I was wondering what would be some of your tips and hints for how to boost the show, so how to boost the attendance, how to kind of spread information about this show, because I do believe in sort of the value of putting public in touch with science and science communication. So how to, if you have some of your tips for boosting the popularity of the show and the attendance, and also spreading the word among potential speakers, experts. We're not necessarily trying to get sort of, the format of the show is is usually 3 people come on the show and give a presentation about the science, the work that they do in a kind of informal settings, which is great for people who are not necessarily always experienced speaking to public about science. But we do also like to host experts. So maybe, because Sean, you probably experienced that sort of finding people for your podcast, but what would be some of your suggestions or advice on how to kind of generally promote this show and get valuable speakers on the show?
Yeah, no, I mean, this is, of course, the question, I think. And the sad news is that there's no algorithm, there's a lot of black magic, and it's really hard, right? You never really know what's going to work. Having said that, if I were to boil it down, I would pick 2 things to emphasize. One is be good, which is easy to say, right? Like, do a show, do a podcast, whatever it is that you would want to watch. It's a little bit hard to be honest with yourself about these things, right? Like, you're doing your best, you like it, but be tough, be self-critical. Watch your show, ask other people to watch it, give you honest feedback. What is it that you can do better? Like, I just published my 83rd episode. I'm not a professional interviewer in any sense, right? I'm trying to become better. I'm learning all the time, and you can always do better. There's some people who are just natural at it. There's some people who are, but those people maybe are not good at doing integrals as I am. So I feel good about that. The other thing is, be a good citizen of the ecosystem. So
Are you watching other people's shows? Are you leaving comments on their YouTube channels? Are you appearing on them? Are you, it's weird to expect other people to watch and support you if you don't sort of reciprocate. You can get known. I mean, I'm still very new at the podcasting thing, but in the old-timey world of blogging, it was definitely part of getting people to read your blog was to read other people's blogs, comment on them, write your own blog post about them, right? Communicate in the wider ecosystem as a good citizen.
Thanks.
Okay, we have a few other questions. One is kind of general. I'm not sure exactly where or to whom this was directed, but what are your approaches to dealing with criticisms to your work? And I think that can be pretty general, but good luck, guys.
Well, I've received a lot of criticism to my work. I work in a very controversial field. I think it's just really useful learning experience, right? You learn what is it that people believe, what can you correct in the setup of how you're putting your talk together, your communication together. When it's in a scientific context, it just sharpens your science. It's really good, right? So it helps you really get to the heart of the matter and do the experiments that you really need to do. In a broader context, you can receive a lot of irrelevant criticism, and it's maybe just not that important to engage with it. So there's no perfection to be achieved in scientific communication. It's always going to be imperfect, and so you're just trying to genuinely try to do your best, and that's really all you could have done. You couldn't have done any more than that. And so if you've done if you really tried to do your best, then just be happy that you did that, and you're done.
Yeah, I think it's important to recognize there's criticism and there's criticism. I mean, there's some criticism that is just not very good, just not very thoughtful. It's not in good faith. They haven't really listened to what you said. You can ignore that. You don't even need to answer it, honestly, especially if it's on the internet. No one is necessarily helped by engaging with bad faith argumentation from somebody. But but it's also important to recognize that some criticism is legitimate and good, some of which you have an answer to, and then you try to answer it in as clear a way as you can. Some of which you have to say, you know what, this is a really good issue. We don't know the answer yet. Not being defensive is really important about this, like being very, very clear about what you do have an answer to, what you don't have an answer to, what you have to do better on, what is still ongoing work, and what has been established. We're all, no matter how much any one of us knows about the world is much bigger than any one of us. We're all struggling to understand everything we can about the world, and to treat it as a communal project rather than us versus them is the way to think about it.
I'll also say that I deal with some people who are like big critics of publishing in a journal like Science. It's very interesting because I meet them at conferences and they're perfectly nice people, and then they'll go and write how horrible science is, and the next day, and sometimes they'll say, and I met the science editor, and it's like, I didn't say anything like that, but you got to just remember it's going to pass, and some people have really loud megaphones on the internet, and some people will kind of pile on, but it does pass.
I'll say that in grant writing, as Sean said, don't get defensive. With reviewer comments, look for a theme, and if all the reviewers are, saying the same thing, that's important. But sometimes they'll say things that aren't important, and when you have to respond to them, don't get snotty in your responses. Respect their opinion, and don't take anything personally. Really, you will suffer many grant rejections before you get funded, so it's just the way it goes.
I think I'll follow Laura's advice and make this an open-ended question, but it's about specialization, because I love all science. I just got a PhD in math studying electrostatics, but I'm starting to feel like I'm missing out on a bunch of other cool science out there if I try and focus on a 200-year-old esoteric subject like electrostatics. So what do you guys think about specialization versus being a jack of all trades and broadening your horizons?
I mean, there's only so much time. So you do have to be realistic about that. But at the same point, you know, Google has this, I think it's, I can't remember whether it's 5% or 10% allocation where you can devote your time to something outside of your primary project. And, you know, that's the nice thing about academia is that it's pretty forgiving for you to be able to do that kind of thing. You may not be funded for it, so you might have to do it sort of outside the grant parameters, but, you know, explore. I will say the best scientists I interact with tend to be multidisciplinary, tend to be very broad thinkers and readers, and they actually do read all of the content, at least, you know, skimming through the abstracts on science rather than just downloading the papers that they get through their Google search hits. So, I mean, I think there's an upside to that. I was someone who was always told I needed to specialize more, and, you know, again, I was preparing myself for a career I didn't know existed at the time, so perhaps there is another career other than research that could help be more fulfilling for you, and that you might need to do a little investigation and exploring.
Yeah, I think, you know, I'm a huge believer in being broad and learning lots of things and thinking productively about lots of things. I'm also, at the same time, a big believer in earning a living. And there's very few people who get to just learn and tinker with anything they want and someone will pay them to do it. And that's as it should be. You know, if we want someone to pay us, we need to sort of give them something in return, as mercenary as that sounds, even in the relatively otherworldly world of academic basic research. You know, we have to do research on things that other people think are interesting, so they will hire us to do it. That's okay. That's not actually a bug in the system. One thing to keep in mind is that just because you do get a job doing a certain kind of thing doesn't mean you have to stop being interested in everything else. You can take online courses. You can study things. You can even start writing papers in a field completely different than what you're actually paid to write papers in. But what you can't do is just insist that you do whatever you want and the world adapt to you. I mean, you can. It's rarely a good success strategy.
One thing we advise our PhD students is that by the time you graduate, you should be a T-shaped person, and the leg of the T represents the depth of expertise that you have in whatever it is that you've specialized in, and the arms of the T represent the breadth. So you can connect to other disciplines, other areas of expertise. You can start collaborations with people who are working on things that are different from you because you can see how your work connects to all of those. I think it's like a very simplistic metaphor, but it's kind of good advice that you definitely want to have depth. There's such a joy in really understanding all there is to understand about a field and to feel like you're pushing knowledge forward in some particular specialization. But there's also incredible joy in being able to make connections and seeing what things emerge from cross-pollination.
I think you should become a grant writer.
I have, I don't know if it's a question or it's kind of not well formulated, so I apologize for that, but it's about Sean's comment about, you know, how as scientists you're getting paid to do what you love, but, you know, technically you're supposed to give back something in return. And the vast majority of our funding comes through public funding, through the government. And I think my question, if I want to phrase it like that, is about, you know, how do you increase that funding? How do you make the public understand that that's important? My own thought about this is one of the major reasons why there's a wall, I think, when it comes to, like, whenever politicians talk about increasing science funding, the NIH funding and so on, that's like a taboo subject, whereas like the defense always gets billions of dollars every year. So I think my thought has been that the public doesn't understand the complexity of doing science, how hard it is to go, you know, how much you have to do before you can even say anything with any level of certainty. And I think in my opinion, there hasn't been enough work in communicating that aspect of science to the public, and I just wanted to hear your thoughts on that. Do you think that's the right thing to think, or if so, what are your thoughts on how to how to better educate the public on that?
I mean, I think there's a lot going on. One thing is, we can't think badly about the public while they are paying our salary. We might want them to pay even more, but I'm amazed that what I do gets public funding at all. Like, I sit in Starbucks and think about the origin of the universe, and people pay me to do this. And so I would like it if even more people got paid to do it, but it still does astonish me that anyone gets paid to do it. I think maybe the most productive thing I can say to what you're talking about is, it would be nice, I mean, obviously science is complex. I don't think that people fail to appreciate that. Maybe they fail to appreciate that science is a process rather than a set of results, right? When we teach science in elementary school or high school, here are the facts you have to remember to be on the test. And the fact that the actual practice of science is so often making hypotheses and being wrong, or failing in your ideas about the world, or throwing away an idea because new data comes in, that is less emphasized. And this fact that we could have been wrong before, but now we do have it figured out, is also underemphasized. So I think the reality of living, breathing science is not taught at a very young age, as I think it should be. Maybe if it were, that would help people appreciate later in life what is actually going on at the cutting edge of scientific research.
I mean, one way to communicate it, of course, is to vote and to call your representative and tell them that this is an important topic for you, and see if you can convince other people to do that, even if they're not necessarily scientists, people who are like-minded. I think certainly they need to hear that on a regular basis. I mean, if that's something that interests you, you may want to look into the AAAS Policy Fellows. So one of the things AAAS does is we will convene a panel for Congress. We don't lobby, but if a topic comes up like the coronavirus, and we'll get experts in epidemiology, and we'll make them available to Congress people and their staff, and they can give a lecture and help explain, this is what we need to be worried about, this is what we know about the virus, this is what we don't know. I mean, there's a lot of work actually going on in that field. And it's not just, getting the research scientists, but it's also the people who can put together, again, the communication, the ability to explain this material to people who really probably have zero science background or not. I'm just going to say, so we had a big news release. This was like over 10 years ago. And there were newspaper reporters and everything. And I was sitting in the audience, and there was one reporter who got up and said, I flunked science in high school. Tell me why I should care about this. And, would anyone get up and say, I flunked English in high school. Tell me why I should be literate. I mean, it was just such an ignorant statement. But for some reason, it seems to be okay to think that you don't know anything about science. And I don't really know how to fix that. But I will say there is more and more public engagement in science. There's more demand for it in the press than there has been in the past. For a long time, newspapers were cutting all their science sections and their science staff, and now there are all these specialty newsletters, and they're getting a lot of traction, so people who are interested in this can follow it. But yeah, I think you need to explain to people why this is important, and that just studying a bacteria might seem really simple, but yet we got CRISPR out of it, and CRISPR is going to be the new gene editing technique that's probably going to work in cancer for people who are having T-cell therapy. And to make those links about really basic scientific research to having larger implications beyond what the actual research is.
Okay, awesome. Do we have any more questions from the audience? A couple more hands. We have about 10 minutes left in our Q&A, so we'll be wrapping up soon. We'll take both these questions.
Sorry, I could probably ask a dozen questions. I listen to a lot of podcasts, but mainly for Sean. It seems like you've made it. It seems like you have a dream job, as far as I'm concerned anyway. Do you consider yourself to have made it? And if not, where do you see yourself going from where you are?
Yeah, no, I certainly have made it in some ways, and I'm nowhere near satisfied with where I am. I think that I have lots of goals in scientific research, stuff I want to figure out and stuff that I have a chance to figure out, but also I want to do more different kinds of scientific research. I want to do things that relate to other fields, whether it's origin of life or complex systems or things like that,
foundations of physics. And I just want to, adventure more broadly intellectually, write other kinds of books and things like that. So there's no such thing as having made it. You can always do more interesting things.
Maybe I can comment on that as well, that we often set up these goals for ourselves that you think, well, once I get that then I will be done. Then I'll be happy, right? Like once I get my PhD, I defend my PhD, I'll be happy. I'll get my job, then I'll be happy. I'll get tenure, then I'll be happy. Whatever it is, whatever things you set up, I'll be elected to the National Academy of Sciences, and then I'll be happy. None of those things are nearly as satisfying as it's always you have to enjoy the process. You have to enjoy like waking up in the morning, doing the thing that you're going to do. Every day is a new 24 hours for you to like really be inside whatever it is that you're doing. And getting those things aren't the things that keep you warm at night. It's really the joy that you find in your work and the people that you work with and the interesting ideas that you get to work with that where all the good stuff is. And it's not bad if you get paid to do what you love. That's very nice, but it's not. You never feel nearly as satisfied about any of those external things as you think you will beforehand.
I mean, or even internal things. I remember when I was an undergraduate, I found this paper that was in general relativity, Einstein's theory of gravity, and there's all these weird mathematical symbols. And I said, like, all I really want out of my science education is to understand this paper. That's my goal, is to understand what's in here. Then I'll have made it. And 3 years later, I'm like, this paper isn't any good. Like, I could have written this. This is no problem at all. And that's as it should be. Like, I don't think that science is something that finishes, or your academic career or intellectual or scholarly career is something that finishes. It can, and that's perfectly okay too, but there's a certain kind of personality that is automatically like on to the next thing that you want to try to do. I mean, that's a big part of why I started a podcast. I hadn't done it, I wanted to try it, and we'll see how that goes, but it's something new and different.
But once Sean posts the podcast that we recorded today, then I will have made it.
Then we will have made it. We will have both made it collectively, yes.
So it's always struck me as very strange that there is such a lack of celebrity scientists in the world, being as that science is pretty important. But kind of going off what Laura said, there is this kind of very general animosity that is directed towards science and scientists by people in the general public for maybe not so great reasons. So my question is, what are your feelings about the development of celebrity scientists as a concept? Do you think they have a good place for developing, some kind of backing and, global interest in science? And should we, as a scientists, be doing more to prop up these people?
I do think that there's something to be said for role models, people who might not appreciate science or know that it's something they could do, could sort of see someone doing it and get inspired by that. But I don't think there should be 5 role models. I think there should be 5 million of them. I think that there's room for, I don't want to have celebrities, I want to have examples, exemplars. We live in a world with the internet where it can be fragmented, and everyone can follow scientists on Twitter, and they don't need to be famous scientists. They follow someone who goes down to Antarctica and studies the penguins, and they just think that's the coolest thing. And therefore, rather than worrying about which scientists are famous and not, all of us who care about scientists should be worried about what are the examples that we're setting. Are we talking to the public in understandable ways? Are we are we just being scolds, or are we being positive? I remember going to a party soon after I moved to Los Angeles, and my wife Jennifer, who was a science writer, and I, met this guy at the party, and he introduces himself as a TV writer, and we said, "I'm a scientist," and she said, "I'm a science writer," and he literally ran away. He's like, "I don't want to hear it," because he had just been used to getting criticism from scientists about his TV show, which was there was a certain medical procedural kind of thing going on, and they cut some corners, right? And the DNA evidence doesn't really come back that quickly, and you know, it's true that the DNA evidence in the real world does not come back as quickly as it does on CSI. But who cares? If that's your science, if that's why you got into science, to tell people the DNA evidence does not come back that quickly, then you're missing out on a lot. Like, if we really get across the passion for the puzzle solving and the process and the discovery and the fact that we don't know things, but we could know them, we can learn them, let's figure them out together, you know, that's, I think, going to be, if all actual working scientists can convey that to the people they meet, that will make the public change their minds about science.
I think maybe one thing I would add is there are costs to being a scientist in the public eye, right? So the things that you find joyful about making a discovery in the lab and sitting with your graduate students and talking in real depth with your colleagues about something you're passionate about, those are all completely different than what the experience is of giving a public talk or going on the radio, where you're going to say the same thing over and over again for years and years, and you'll get the same questions over and over again, and you're engaging at this very, very shallow level, and you're constantly engaging with people where, you know, they're really just at the, you know, really understanding the very edges of what you do. And it's a fun challenge if you're passionate about education and spreading knowledge. It's really worthwhile doing it. It can be very gratifying, but it's a very different kind of gratifying, and it's a very different kind of intellectual engagement than you get from the lab work, right? So you're making a big trade-off in your time and how you're allocating your times. So I can completely understand why a lot of scientists are not that interested in doing that, because a lot of your time is spent doing something that's very repetitive and not intellectually very challenging, even if it's rewarding and worthwhile to do, right? So it is a trade-off.
Thanks.
All right, awesome. I think we'll let that conclude our Q&A session. Please join us outside for our happy hour with our speakers. Thank you again for joining us and learning something about sharing science to the general public.